Okay, so it's really easy to do the dot product if you remember what a dot product is. Okay? And if you don't remember, you remember right now. Okay? You multiply the I components, multiply the J components, right? So R dot dr is what? I component times, I component times I component, right? What are you going to get? You're going to get a 4 and a 4 pi over 3 giving you 16 pi over 3, right? And you're going to get a negative sine times cosine. Okay? And on the J components, you're going to get the same factor, 16 pi over 3, but it's going to be times a sine cosine, right? And the sine and cosine are the same thing. They're of opposite signs. They're going to add up to 0, meaning that this dot product is 0, meaning the cosine of phi is 0, meaning that phi is pi over 2 or 3 pi over 2, right? But it's not 3 pi over 2 because the cosine of 3 pi over 2 is negative 0. No, that's all right. Okay, it's a right angle, okay? There's no negative 0, I was just kidding. Okay?
So it is perpendicular.
Huh?
So it is perpendicular.
So it is perpendicular. Now, just to complete the calculation, you get 16 pi over 3 times the cosine, and I'm just going to put parentheses here because we know that in every expression we got the same thing in parentheses. So just to abbreviate it and save us a little time, and okay, it's cosine times a negative sine, but that's going to be negative cosine times a sine plus sine times cosine. So cosine phi equals 0, phi equals pi over 2. So the vectors are perpendicular. And now I can replace this wavy vector here with a vector perpendicular. And that we now see to be a right angle. And it goes this way because the I component, in the first quadrant at least, would be negative, and the J component would be positive, putting the dr dt vector in this direction, okay? Not this direction. Make sense? Okay? Well, okay, that's good. Now, what is the derivative of a position vector? What's the derivative of position?